Good afternoon, folks. Let me just share my screen and we can start. Right. Can we see my screen?
Yes, sir.
Okay. Right. So before we start, I want to give a little bit of context to what we're going to cover as part of this. I'm not 100% sure as to how many of you are actually well versed with the blockchain, cryptocurrencies, and these sort of terms. So I'm going to keep this talk fairly basic. I'm going to cover a bit of the foundation, build on the fundamentals, and then if there's anybody who wants to understand the complexity as part of it, we can take it up as part of the questions. Right? So our talk today, we're going to talk about securing the blockchain, right? So again, as I said, we are going to start our discussion with what do we even mean by blockchain? What do we even mean by security? We will talk about a particular implementation of the blockchain because blockchain is a very generic term. It can be implemented in many particular ways. We will talk about one single implementation of blockchain which has been successful, which is in cryptocurrencies. Right. So let's start. Right. So first, before we proceed any further, I want to give you guys a perspective to look at the entire system as a whole. Right. So what do we mean by security in the first place? Right. So when we say security, we are building a system. Securing the system means the ability of that system to meet its objectives in normal conditions, of course, and also in adverse conditions, right? How are we making this possible? This will change from system to system, right? I've presented a bunch of small icons and diagrams on the right-hand side, which gives you multiple different solutions as part of security, right? It could be CCTV cameras, it could be fingerprint scanners, it could be physical security that is at the site, it could be security that is built into the application, it could be network security. All of these things factor in to give us the ability of the system to be able to meet its objectives even under adverse conditions, right? But before we try to go into blockchain, I want us to understand that there is a fundamental change in how security should be looked at when it comes to particular type of systems, right? Because we're not dealing with the traditional centralized type of a system. We are dealing with a decentralized open system. So our entire perspective of how we look at this must change drastically, right? So I'm going to present two different design choices for you. Let's say I'm trying to build a solution today. I'm trying to build a centralized solution versus I'm trying to build a blockchain-based solution, right? What should be your perspective when you look at security? Design choice one is what the traditional systems use. We also call this security through obscurity. We sort of build a system and your security is sort of external to this. There might be some small aspects of security that is built into the system, but most of the security features are external to the system, right? Almost every picture that I've shown on the right-hand side is external security, right? It's not something that is baked into the system. It is not something that is intrinsic to the system, right? So your system operates. This sort of security, this sort of design choice works great when you're dealing with closed systems where nobody gets to see what exactly the system does, how it internally functions. So you hide the system from anybody who is a malicious attacker. And then you make sure that you put in multiple layers of security before he can reach that particular object, right? But when we talk about something like a open public blockchain, that does not work, right? Why? Because the type of system that we're going to talk about is an open system. That means anybody can participate, right? I can use my laptop to participate in an open decentralized system. There is nobody in control, right? So if anybody can participate, anybody can take control of part of the operations, anybody can do what they want to do, contribute in any way they want to the system, it becomes very difficult to use design choice one, right? So as part of design, we'll have to look at something called design, which is design choice two. That means security has to be built into the system, right? The system itself has to have intrinsic ways of securing itself, right? Which means internal mechanisms, which means incentives for, like, as in positive incentives for people who are upholding, as in honest participants of the system, punishing participants who are basically harming the system. We're using things like game theory, right? So there's a whole bundle of things that comes in when we are dealing with the second type of system, right? So I want us to be aware of this through the entire talk, because we are dealing with a system which requires us to look at security in a different way, right? You can't just say, I'm going to write something, piece of code, run it somewhere else, and then keep that secure by putting multiple layers between that system and the attacker, because this is not the type of system that we are running. In this system, anybody can participate, anybody can join in, and it becomes very difficult for you to build that. That means you have to build internal mechanisms to make sure that the participants of the system uphold the system, maintain the integrity of the system, right? So to keep this as the backdrop, we are going to start with our talk, right? So as I said, I'm going to keep this very, very basic. Let's try and understand what is the scope of our discussion today, right? We're going to talk about what is a blockchain. This is going to be one of our primary discussions. As part of that, we will talk about the most successful implementation of blockchain, which is cryptocurrency, right? We understand there can be many other implementations. I'm not going to dwell into that in this talk, but this can be a foundation for you to understand what is blockchain, and then you can think about where else it can be used. And the security aspects of the system will change depending on what the system is trying to do, right? Our security talk is going to be related to how is the cryptocurrency part of the system going to be secured, right? Even cryptocurrency, we understand there are 10,000 coins out there, right? So at this point, we are not going to talk about every one of them. We are going to limit our entire discussion to one of the cryptocurrencies, the first one, and I would say the most successful one, right? Which is Bitcoin. We will talk about Bitcoin in a fairly comprehensive way. Bitcoin is a once-in-a-lifetime invention. We need to understand that Bitcoin has multiple dimensions to it. It can be looked at from multiple perspectives. For example, if you are a technical person, you might be interested in the technical side of Bitcoin, and that's what draws you in initially, right? But once you understand Bitcoin from a technical perspective, you will ideally have to step back and understand that there are multiple ways of looking at Bitcoin, right? Because the system does not have influence in just the tech realm. It has influences in many other realms. For example, there is technical aspect, there is monetary financial aspect, there is security aspect, there is cryptographical aspect, there is ideological aspects or framework for Bitcoin. There are political influences regarding Bitcoin. So there are multiple implications to this particular one system that exists. In our talk, we are not going to dwell on all of these things, right? We are going to limit ourselves to one side of things only, which is the tech side of things, and primarily the security side of things, right? But keep in mind a caveat that a system like Bitcoin cannot be explored or understood unidimensionally, right? You will have to look at the multiple perspectives to get the full picture. We will look at one side of it because our talk is limited to a certain time period, and we are trying to focus on one aspect of it, right? Okay, let's start. Now, before we proceed further, I want to just to get the feel of the room. Everybody here, I'm hoping, has a smartphone in one way or another, or has access to a computer. We'll do a small survey, right? You can either scan the QR code that you see on the top left corner, or you can go to slido.com and put the meeting number as 693721. It will give you an option to answer this quiz or a poll, so that I get the feel of the room to see how many of us are actually part of the Bitcoin, how many of them have heard about it, how many of them have understood it or used it, or this is the first time that we're encountering this entire field as a whole, right? If you guys can take a minute and then answer this, that'll be great. Okay. Right. If there's any issues with the link or anything, please do let me know. Right. So you don't have to put.
Excuse me, sir.
Yes.
So presentation is stuck on the first slide.
Is that so? 1 second.
Yeah, it's quite good now.
1 second. 1 second. Let me just. Okay. Right. Can we see the presentation with the security aspect?
Where on the slide have we heard of cryptocurrency before?
Okay, this one.
So it will stuck on the same, sir.
1 second. 1 second. Let me just unshare and I'll reshare it. I'm sorry about this technical difficulties. I'm going to stop share. And I'm going to reshare the entire desktop to make this easier.
Yeah, absolutely good now, sir.
Okay, fantastic, right? So if we can see the poll, right, there should be a QR code on the top left-hand side corner. You can, if you have a smartphone, please use that. If not, you can go into the web link, slido.com. There, it'll ask you for a meeting number. Put the 693-721 as the meeting number, and it'll give you this particular question, right? Please go and answer this so that I get the feel of the room, so that I can calibrate my talk accordingly, right? Folks, is the link accessible?
Yes, sir. Yes, sir.
Yes, yes.
Okay, fantastic, right? Every one of us has heard of it, but they have not used it. Fantastic, right? Now, that's great. We will build on that. Now, if you stay on the same screen where you were, it'll ask you the next thing. Can you mention some of the cryptocurrencies that you've heard? Right, it should give you a prompt to type in. Fantastic. Bitcoin, Ethereum. Anything else? Right. So understand that there's about 10,000 of these coins. There will be plenty of things that you might have heard of. We are going to focus our entire discussion on Bitcoin. Right. But once you understand Bitcoin, maybe you can go and look up other of these to try and understand how it works, so that we get a fundamental, right? So fantastic, that's good, right? So you can keep the screen alive. There is an option for Q&A as part of the screen as well, right? If you have any questions that you encountered during the slide set, please do put it in the Q&A, and we will take that at the end of the session, right? So Dogecoin as well, that is extremely popular, absolutely yes, right? Okay. Right. So let's start from the absolute basics of our discussion. Right. That is, what is a cryptocurrency? Right. So to put it simply, there are two words associated to this. There is crypto and there is currency. Right. So cryptocurrency basically is a digital currency, which is an alternative form of payment that is used, that uses encryption algorithms. Let's call it. Right. So there are two words here. There is crypto, which comes from cryptography, and then there is currency, which means money. We'll try and understand what each of them mean. First, what is cryptography? We understand that it is the art and science of doing secure communication. Right? How does this work? You are trying to send some information to somebody. let's say that you're using post or some sort of mechanism to send it. I don't want the postman or anybody else in the actual path to be able to read and understand what I sent. I want it to be a secret till it reaches the destination. How do I go about doing this? I use something called cryptography, which means I encrypt the information that I'm sending, which basically garbles the data, and the destination, the recipient, has a key using which he can decrypt the data and then get the actual information. That's what cryptography is, right? So there are a whole bundle of examples here. I've shown you a bunch of pictures, right? Some of them are really, really old. We understand cryptography is not new, right? It has been in practice since World War I and even before, right? Again, some of the tools are from World War I. Some of them are from older systems where secure information and secure communication has been something that is required for a long time, right? So what are the different use cases of cryptography, right? First one, we talked about just now, encryption. I don't want anybody to be able to read my information. It could be information that I'm sending to somebody or information that I've stored within my system, right? So instead of writing it in clear text, I'm going to write it in ciphertext. And I make sure that anybody who looks at that information cannot understand what it means, right? That's the first use case. Second, using the same way of garbling data or using cryptography, I can ascertain identity, right? I can use the same cryptography to uniquely identify a particular identity and only then offer a particular service or do communication or something along those lines. Right. So the third use case is integrity, right? So we might have heard of something called a hash function, which is a one-way function. That means you take something and then you run it through a hashing algorithm. It will give you a result of set value. It could be 256-bit, it could be 128-bit, right? And each bit that you change on the source will drastically change the destination, right? And it will give you one unique value for anything that you type in. You might have heard of a whole bunch of hashing algorithms. There is MD5, there is SHA-256, etc., right? And we also can use the cryptography for non-repudiation. Non-repudiation means if you have done the transaction and if you've signed with your cryptographic signature, you can't at a later point of time obfuscate and say it's not mine, right? It can be used to basically assign ownership of something so that the guy who made the transaction cannot obfuscate. That is non-repudiation. You can't repudiate because the cryptography proves that you were part of this, right? These are the different use cases. Now, there are three different types of cryptography that is being used in the world right now. There is symmetric, there is asymmetric, and there's hash functions. Symmetric just means that the same key is used to encrypt and decrypt. That means you will use one key to encrypt the data. The same key can be used by the recipient to decrypt the data. This example that you see, the wooden log on which you have the leather this thing, that is symmetric encryption, which basically means if you know the size of the log, if this destination, if the recipient has the same size log, he can use the leather strip and be able to understand the data. We are using the same key to encrypt and decrypt, right? Asymmetric means there is two different sets of keys. This is also called as public key cryptography. There is a public key and a private key. If you encrypt using one, you can decrypt using the other, right? So, and the third one is hash functions that we just talked about. As part of our system, we use asymmetric, which is public key cryptography, and hash functions. We use the public key cryptography for authentication, and we use the hash functions for integrity maintenance, right? So we will understand this in a lot more detail. I will try and tell you what exactly the Bitcoin network is going to do, how exactly we use these keys, and all of this in a lot more detail. This is just giving you an overview of what is cryptography. Right? I'm sorry, was there a question? Right? If you have a question, please feel free to unmute yourself and ask. That's perfectly fine. If it is relevant to the slide we are talking about, I will address it right away. If it is not, then we can keep that to the end of the session, right? So moving ahead, again, if we go back, we were talking about cryptocurrency, which means we have just addressed the crypto part of it. Now we'll address the currency part of it. What does currency or money mean, right? So at the end of the day, money is something that we use in exchange for services, right? How did this come into picture? There are two theories about the origin of currency. The first one is barter theory, and the second one is called a debt ledger theory. So I'm going to talk about the first theory in a little detail to give you an idea of what we're talking about, right? So let's say back in the day, there were multiple players as part of the system. I have bananas, somebody else has apples, somebody else maybe went for a hunt and then they came back with a deer. Now we need to exchange these things. I can give my bananas, and then in exchange, the deer can be obtained from the guy who hunted. Or I can give my bananas, and then in exchange, I can get the apples from the apple plucker, the gatherer, right? Now, the problem with this kind of a setup is I have to keep track of every one of these items that exist in the unit of bananas, right? I have to keep track of how many bananas for, let's say, 1 kg of meat, how many bananas for 10 apples, how many bananas for a particular service, how many bananas for rice, etc. I have to keep track of that, right? And usually everybody has to keep track of every single commodity because the prices may change, right? So this is a very difficult system to keep track of. So what we came up with as part of the evolution is we are not going to use our own services to price these things. We are going to use something that is external, that has no intrinsic value of its own, some sort of a token. It could be gems, it could be seashells, it could be cowrie shells, it could be whatever these are. I'm going to use one of them to represent value, right? We're going to use that to measure every commodity, and then we use that in exchange for our goods and services, right? That's the barter theory, right? The debt ledger theory also does the same thing. It says, let's say I went for a hunt and then I came back with a big deer. And then I have to give it to everybody in the community. I have to keep track of who did I give it to, who owes me favors, etc. So to maintain that, we came up with a system. The end result of both of these systems are you came up with a token that can be used to represent value, right? That can be used for transactions, so that you didn't have to measure everything of every single commodity. Because that's difficult to keep track of, right? Now, we also understand that currency has gone through an evolution, right? In the very beginning, maybe we use tokens, right? It could be rare tokens, that the thing we talk about. There are certain characteristics of currency as a whole. It must be rare. It must be unique. It must be divisible. It must be fungible. It must be fungible, etc. Right? So these sort of characteristics exist, and it has gone through an evolution. In the beginning, we started using rare tokens, which could be anything, the cowrie shells or gems or whatever. And then we moved on to precious metals like gold, silver, bronze, whatever. And then we moved on to paper money. Again, this has gone through an evolution where gold, as great as it is not really a fantastic thing to carry around, right? So you wanted a better tool. So you could go and then deposit gold with a blacksmith or with some sort of institution. They would give you a receipt, and then we started trading the receipts instead of actually trading gold. This first started in China. They were called Janissary notes, and basically it caught up, and that's why we got paper money, right? So from paper money, we've moved into plastic money, which is your debit card, credit card that can be used for transactions. And then from then on, we've moved into digital money, which is basically Paytm, Airtel money, etc. Right? What has actually changed from that evolution? The current stage of the evolution that we're in, we're using cryptocurrency, which is nothing but network-based money. Right? That means there is a network. This network will accept this particular money. It is the job of the network to maintain and run and put systems in place that will do the transactions for you, that will help you keep track of what is the value of that money, all of that, right? We will talk about the Bitcoin network in a lot of detail, but just to give you an idea of what we are referring to, why are we talking about money in this case, is because the current form, which is the Bitcoin, can be considered as network-based money, right? And I want you to understand one more thing as well. Again, money is a very, very large topic. I'm barely touching the surface when I'm having this discussion. There is the other transformation that every token or currency goes through, right? So it starts off as a token, right? And at one point, it will have enough value. People will value it enough that it will become a store of value. And then it will move on to a medium of exchange. That means people are using that for exchange of services and goods. And finally, it will move on to something called a unit of measurement, which basically means I'm going to price every commodity in multiple units of this currency, right? Again, not every currency will actually go through the entire cycle. Some of it might stop at a particular point, right? Because if it needs to be a token, there are certain characteristics it needs to have. If it has to become store of value, there are certain characteristics it needs to have. If it has to become a medium of exchange, there are certain characteristics. And if it has to become a unit of measurement, there are different characteristics, right? So for example, if it needs to be a token, it just needs to be rare, right? So for example, you will notice that if you are a tribe which is in the mountains, you will not use rocks or gems as part of your currency. You will use seashells, right? Because it's rare. But if you are in the beach, you will not use seashells because anybody can go fetch those and then inflate your entire system. So you will use gems and precious metals. Something that is rare will be used as a medium for that particular transaction, right? And store of value basically means this. If I keep my wealth in this particular format, in this token, it will retain its value over time, right? For example, if I keep my wealth in gold for 10 years, 15 years, 20 years, it will retain its value. But if I keep it in rupees, because there is inflation and there is new money printing that is happening, the value will actually reduce, right? So if your currency has to become a store of value, it must be able to retain its value over time, right? So same thing for medium of exchange. If it wants to be medium of exchange, that means there must not be very high volatility, right? For example, Bitcoin at this point in time is moving from token to store of value. It is not medium of exchange because it is very, very volatile. Sure, Tesla can come and tell you that we will accept Bitcoin for giving you a Tesla. But let's say that the price of Bitcoin today will not buy you a Tesla. The price of Bitcoin tomorrow will buy you a Tesla. A year from now, it will buy 2 Teslas, right? And then 6 months later, it can buy you half a Tesla again, right? So if it is a volatile currency, it will not be used for medium of exchange, right? So the same thing for unit of measurement as well. Unit of measurement also needs stability, right? So this comes with time in certain ways. For example, when there is adoption, when there is enough people who are using it, they will make sure the system behaves in a particular way, right? But we need to understand when we're dealing with a currency, these are different properties that are in play. And when you talk about a cryptocurrency, your system, which is basically the blockchain system that we are going to use to implement money in the network money format, has to take all these things into account, right? So Bitcoin is actually designed to have characteristics of each one of them, and when it reaches a certain stage, it can take over that responsibility if the public or the society feels it is an optimal resource or an optimal commodity to do that, right? But in general, when we talk about money, I'm just bringing in a few concepts that we need to aware of, because this is our implementation, right? We are using cryptography, we are using blockchain, we are using a bunch of tools to do one application, and that application is money, right? Any questions so far?
There is a question in chat section, so please check.
Okay. Right. I'm sorry, I'm a little new to this Google thing.
Okay, if I will just read it out for you, sir.
Perfect, thank you.
Yes, sir. It says, isn't it risky? Isn't it the risk of purchasing Bitcoin very high then?
So the point is this, right? So we are not going to talk about price movement as part of this discussion. We are going to limit our entire discussion to, let's say, the tech part of it, right? Before you invest in any asset, we need to be aware of what exactly is that asset, how does it work, right? So we are not going to talk about the price movement as part of this. I'm just giving you an idea of what is the problem that Bitcoin is trying to solve, right? Sure, it is risky because, again, we don't know if it's going to work. We don't know if the people are going to adopt it, right? So we can look at it from the tech perspective to tell us, is it secure enough in terms of tech, right? So is it secure enough when it comes to the fundamentals for using the math, using the cryptography? But we will not be looking at it from price movement or trading perspective as part of this talk, right? Because that requires a very different perspective altogether, right?
Sir, I need to ask, since it's very much unstable, we cannot, no one can guarantee when the prices are going to be up or when it's going to crash down. It can crash down at any moment.
Sure.
So, if there is this much risk in this thing, why are people investing in it so much? Like, uh, people all over the world invest in different type of cryptocurrencies.
Right. So I'm hoping, but by the end of this talk, you understand why people like it, right? So as I said, for us to invest in something, we need to understand how it works, right? So if the actual engineering and the mechanics of it is sound, but this is also giving you money, which means right now 80 to 90% of the people who are investing in Bitcoin, they don't know the value and how it works. They're only investing in it because they think the value is going to rise, right? Now if they don't know the fundamentals and if they're holding on to an asset, if the price starts dropping, they don't know the value of what they're holding and they're going to get rid of it as quickly as possible, right? So because of that, there is volatility in the market because majority of the market doesn't understand the assets, but they hold it because they think others find it valuable, right? It's the same thing with stocks, right? Let's say that somebody told you this company is fantastic and there has been a lot of social media hype, and you pick up that company. When you buy, the price slightly increases. When many people start buying it on the market, because there's demand, the price goes up. At one point, it is no longer the value of that much, so some people start selling it. The value starts going down. People see that it's going down, they don't understand the asset that they're holding, they start selling, and then it'll go through a tumble. So this is that kind of an asset at this point, so you have to be careful. So again, as I said, we are not talking about the price of it, we're not talking about the trading aspect of this as part of discussion. I don't want to concentrate on that, right? I want this talk to be primarily about the technical part of it, right? I want you guys to understand what is the system, what does it take to secure the system, right? And then you do your own research, and if you think it is good enough, then you can think about investing at a later point of time. You should not be investing in anything that you don't understand, right? Again, I'm going to leave that part here. If there is any questions related to trading or pricing, I'm not going to take it, right? This is going to be mainly focused on the technical aspect and the security aspect of the talk. Okay. All right.
So please share the screen again, sir, please.
One second, I'm doing that. Right? Can we see my screen?
Yes, sir. Yes, sir.
Okay, fantastic. All right. So we are talking about what is currency. I hope we have an idea of what is currency, right? So we understand there are different types of currencies that exist in the world. Bitcoin is just one of the new ones. We will understand why it is relevant. We will understand what exactly is the system that is in place. We will understand what it takes for us to secure this system, right? So before we proceed any further, I want us to understand the primary difference between a traditional form of money versus excuse me, the decentralized form of money that Bitcoin or any cryptocurrencies will bring into the table, right? So there's a whole bundle of underlying characteristics of the system that we need to understand, right? So let's try and look at the differences first, and then we'll drill into Bitcoin specifically. First, if it's a centralized system, we understand what it means to be a centralized versus decentralized system. Yes, a centralized system means there is somebody in control. There is some institution, some organization, some committee, some government, some society which is in control of how the system works. If it's a decentralized system, there isn't really one point of control. It is distributed and decentralized, where there is a whole lot of responsibilities that is split between a whole list of participants, and one participant cannot take over or take control of the network or take control of the system, right? So we will try and understand what changes when you talk about the centralized form of money versus the decentralized form of money that Bitcoin brings to the table, right? First, Bitcoin or decentralized structure offers you something called control resistance. Control resistance means nobody can control the network, right? That is not the case in a centralized institution. Your money systems are actually controlled by somebody. The rupee is controlled by the RBI, the banks, the Indian government, etc. The US dollar is controlled by the US government institutions. Any form of money or system that you have is centrally controlled by some authority, right? In a Bitcoin environment, there is no control. Anybody can jump in and participate. That means I can join the network today and I can choose the role of being RBI or a commercial bank or a trader or a user or an exchange. Any one of these participants, any one of these roles can be taken by any participant. Of course, there are underlying things that you have to do. For example, if you want to be a miner, there are certain requirements that you need to fulfill. If you want to be a developer, there are certain requirements you need to fulfill, but that the system does not stop you from assuming that role. And any community, it could be developers, it could be miners, it could be users, they cannot take control of the system and make it work the way they want to. If you want to make the system do anything, every participant has to agree, right? Every participant has to agree to what you're saying, only then the system moves in that direction. If there is enough people who say, I don't want to follow this particular new update, I don't want to do this particular move towards a new design, then you cannot move, right? We will understand this in a little more detail later on, but for right now, understand what it means to have control resistance. That means nobody can take control of the network and then make it do whatever they want. Everybody is in control, nobody is in control. That's the system we are dealing with. You have to get in consensus, which means everybody has to agree to move in a particular direction, right? And again, when I say control resistance, from whom? Application cannot be controlled, the infrastructure cannot be controlled, it cannot be controlled by any authority, developers cannot control it, network creators cannot control it, operators cannot control it, exchanges cannot control it. They can participate and they can work with the network, they can follow the rules of the network, but they can't take control of the network and make it do whatever they want it to do, right? First key. Second, decentralized system offers you something called censorship resistance. That means the network cannot censor anybody. One person in the network cannot censor another person, which happens all the time in a centralized environment. For example, Twitter can decide who can put content on their platform, who cannot. If you put something which the Twitter management or the team doesn't agree, they can shadow ban you, they can kick you out of the network, they can suspend you for 24 hours, etc. Right? Because there is a centralized authority, they have the power to do that. Same thing when it comes to banks. The banks get to decide who can open an account. What do you need? You have to do KYC, you have to have a certain eligibility, you need to have a certain CIBIL score, etc., to do transactions. If you do not have this, they can cut you out of the equation. They can say, we are not going to offer you services, right? That is censorship resistance. In banks, it is actually even more. For example, your money is in your account. The banks can decide who you can send it to and who you can't. Right? They can say this organization has been blacklisted. You can't send money to it. Right? That basically means that even though it's your currency, the centralized institution is in your path and it can allow or deny things for you. Right? This is inherently built into the system, but a decentralized system is built in such a way that you cannot control it. Right? No participant in the network can censor another participant. Anybody can do absolutely anything they want as long as it is in line with the network's policies. Right? Third, it gives you something called immutability. That means once your transaction is been done, is been written into stone, it cannot be modified. Right? In a centralized institution, it's a database. You can change it, you can modify it if you have enough authority. Right? But in a decentralized system that we are talking about, again, please keep in mind, not every decentralized system will have all of these characteristics. The decentralized system that we are talking about, the blockchain-based money system, which is Bitcoin, has these characteristics. So your general decentralized systems can have more or less of these characteristics. We are only talking about these things because they're relevant to us right now. Right? Immutability means once it has been written into the block, it cannot be modified. Your transactions are set in stone. Once you make the transactions, it cannot be recalled, it cannot be modified, you can't do anything. There is a permanent record of that transaction written on the blockchain. Right? Next, it uses private key encryption. The centralized system may use it, may not use it. It's left to the developers. It gives you transparency of application code in runtime, which again is also called as open source, which means you get to see what the system is doing at any point of time. You get to see what the system does in the application. What does each of these nodes do? What does the network do? You can find out all of this because it's open source, it's public knowledge. Right? If you have enough knowledge and curiosity, you can find out how the system works. Everything is in the open. The centralized systems don't really have this. Right? They work in a different form of security where you don't know how the system works, and that is considered security. Right? You don't know how the internal system is working. It is proprietary. You are not allowed to open the source code and see what it does. You're not allowed to see what exactly is happening in runtime. All of these things are built into the centralized infrastructure. Right? That means if you're going to build a system in the centralized design, you'll have to usually take these things into account. But if you're building it in a decentralized system, then these characteristics are usually part and parcel of it. Right? So I want you guys to understand the difference in design so that when we proceed further, we'll try and map this into how exactly the Bitcoin network is doing these things. Right? Next, there is something called permissionless. There are two types of blockchains. We will talk about that a little later. A permissionless system means I don't need permission to join or work in the system. Right? I don't need to go to an authority and get permission to join the Bitcoin network. I don't need any permission from anybody to participate in the Bitcoin network or make transactions or basically do anything that the system allows me to do. Anybody can take on any role without actually getting any permission. Right? That's what the system is. In a centralized system, that is not the case. Only authorized systems can see it. There are different responsibilities. A developer will not be able to operate. An operator will not be able to develop. A infrastructure administrator has limited permissions. A network administrator has limited permissions. The guy who's using it doesn't get to see a whole bunch of these things. He just gets to see what he can do and what he's capable of without actually understanding the entire system as a whole. Right? He can't switch roles and responsibilities without permission. He needs permission to be able to view anything inside the system. That's how the centralized system works. Right? And next, there is something called borderless. That means your decentralized system, again, our decentralized system, which is blockchain, Bitcoin, does not recognize borders. No political borders, nothing, right? Because it's a global, universal system. Anybody can participate from any country. There is no compliance. There is no borders that can stop you. but the centralized institution cannot work that way, because there is a particular institution that can be held liable, that can be pressured into doing things, or that has to follow the rules of the land, that has to follow compliance regulations, that has to follow where the data must be kept, and all of these things. So your centralized institution will have to take all of these into account, and it cannot be truly borderless, right? Finally, your decentralized system, our particular decentralized system, gives you something called a trustless system. A trustless system means for me to participate and work and do things, I don't need to trust anybody, right? The system is very open, it is simple. If I understand how the system works, I can do whatever I want with it. There is no need for me to trust anybody to do anything in the system. But that is not the case in Central. For example, if you put your money in the bank, you have to trust that bank to hold custody of your assets or wealth or money or whatever it is, right? Any institution, any centralized institution requires trust in that organization, without which you can't proceed. If you don't trust that organization, you will not be able to make a transaction with it, right? That means trust has to be built into the system. In this, we say we make the system open and transparent enough that we by default make the mechanisms so that trust is not part of the equation for me to do anything in this network, right? I understand these are all very, very heavy terms that I'm bringing in. I want you guys to try and place these things when we try and understand the Bitcoin network, right? The reason I'm talking about this in so much detail right now is I want you guys to understand that there is fundamental differences between how a centralized system works versus a decentralized system works, right? So to throw back to our original discussion, we said we're going to talk about cryptocurrency. We said we're going to talk about security of it. Why are we circling around these things? We are dealing with a system which will use the design choice tool. That means security is not something external to the system. It has to be built into the system, right? It has to be intrinsic, which means for me to understand the security, I need to understand how the system works, right? I need to understand what are the checks and balances which have been built into the system that make it secure, right? Who can do what in the network, right? Who are the stakeholders? What are their responsibilities? What are the incentives that the system places within the network to make sure that they do what they're supposed to do? What are the punishments or disincentives that the system uses to punish those who don't follow the system, right? So because it is not something external, we need to understand the system in detail to be able to understand how it is secure, right? I hope I'm making myself clear. I understand that this is a lot of jargon, but hopefully by the end of this will make sense as you're able to place these different properties into the network and see where they fit in and how they help you, right? So moving further, let's first talk about, before we go into how Bitcoin works, let's talk about what is the value proposition of Bitcoin. Somebody asked me earlier saying, why are people going into Bitcoin? Why are they purchasing it when it's so volatile, right? So we need to understand that when Bitcoin as a system has come alive, it has a certain value proposition. That means, what is it bringing to the table? What exactly is it going to offer you, right? We need to understand that first to say, what does this system do? Then we need to understand, how does this system do it? And then we'll understand how is it secure, right? So first, the first thing that Bitcoin offers you is it is decentralized and it gives you control resistance. That means every participant in the Bitcoin network is a participant and there is nobody who is in control. Anybody can take up any role and the network will proceed, right? That means you can log in to the system and then become a regular user who's doing transactions. You can become a trader by going into an exchange. You can open up your own exchange. You can become a miner. You can become a developer. You can do any of these things without actually asking anybody's permission, without actually being able to control the network or the system as a whole, right? For you to be able to move the network in a particular direction, every other participant has to agree, right? That's what we mean by decentralized and control resistance. That means Bitcoin is effectively giving you that system which cannot be controlled by a central authority. That means anybody who wants to join the network can participate, and he has enough control to decide the direction that the network will go, right? First thing. Second, it is permissionless. Anybody can join it. Decentralized means whoever is part of the system, there is no centralized control. But you can always control who gets to get into the system, right? Permissionless means anybody can get into the system, right? Anybody with a computer, with a laptop can get into the Bitcoin network, right? Which in turn gives you economic freedom in one way. It is borderless. There is global access. There is no limitations of borders. There is no limitations of countries or states or race or ethnicity or anything, right? Anybody can participate. It is a global network. It is sound money. It gives you a fair monetary policy. What does that mean, right? It means how each and every Bitcoin is generated is an open document, and it is being followed by the network to a mathematical precision, right? That means nobody can go and say tomorrow I'm going to generate 100,000 Bitcoin. That does not work, right? The system will follow a particular procedure as long as the system is alive, right? There is a set number of total Bitcoin that will ever be minted, which is 21 million. Right? 21 million is the final number. It's almost 21 million, right? So 21 million Bitcoin will be minted, and there will not be another coin that will be minted. That means it is a set, this thing. It will not be inflated, right? Nobody can come tomorrow and then increase the supply on you. That means it is just scarcity is built into the system, right? Gold is not that scarce, if you remember, right? It is scarce, absolutely, yes, for right now. Imagine tomorrow you find a gold mine which has 10,000 tons. You understand that it instantly became inflated, right? The prices will drop in one way or another. But Bitcoin is controlled inflation, and it is set. It is not an inflationary asset. It is a disinflationary asset, which means the total amount of Bitcoin that will ever be printed is set in stone, that will not be changed, right? And how they can be transferred, what are the things that you can do with it within the network are all set in stone. These are part of the protocol. They're open. You can clearly see it. Anybody who wants to participate in the network can understand how it works, right? That's what we mean by sound money or a fair monetary policy. It is censorship resistance. It will not control anybody to say you can participate, you cannot participate. It will not censor anybody to say you can send money to this person, but you cannot send money to this person. That cannot be done because it is a decentralized network where nobody is in control. You cannot say one person is going to control another person's transactions. That will not happen, right? That is built into the system. It is irrevocable or immutable. That means once a transaction is completed, it cannot be reversed, right? It is set in stone. If you send it by mistake to somebody, it is set, right? If you lose your keys, you have lost the coin. It's like you have donated it to the universe, right? Out of the 21 million coins which are going to be minted, it's not all minted yet. 4 million, about 3 to 4 million coins have been lost already. That means they will never be retrieved. They're gone, right? So the system has a very sound policy in terms of what happens inside the network. It gives you public governance. Anybody who's participating in the network can decide the direction of the network, right? That means governance as software. You have also heard of this phrase called law is code, which basically means whatever has been coded is law within the Bitcoin network. Finally, it gives you security. Again, security comes in different ways and forms. We're going to talk about two aspects of security. we use the public key, private keys to give authentication of the spender. And second, we use hash functions to maintain integrity of the blockchain of transactions. Right? So again, all this at this point might seem like rhetoric to you. I'm just stating a bunch of things that Bitcoin is going to deliver. Right? Why do people care about Bitcoin? Because since its inception in 2008, 2009, it has followed all of these to the letter. Right? It has been doing everything that is stated out to do, and it has not faltered once. Nobody has been able to hijack the system, take over the system, hack the system, etc. Right? They have not been able to do that for Bitcoin yet. That is why people trust Bitcoin. Right? Now, this is all what it offers. Right? When we move further, we will try and understand how the system works and how it offers these things. Right? Any questions so far? Okay. Right? Moving further, what is a blockchain? Right? This should have been one of the first things that I talk about, but I want you guys to understand where does the blockchain fit and what exactly does it do. And before that, understand the foundation in which the blockchain is going to sit. Right? Now, first thing, blockchain is not new. Blockchain has been in implementation since 1991. Right? Blockchain by itself isn't really an innovation also. Right? So what is a blockchain? It is a decentralized distributed ledger that is immutable. What does that mean? It means something that you write onto the blockchain cannot be modified. As simple as that. That's all that means. Right? We understand what a ledger is, right? Ledger is nothing but a transaction list, right? How much do you owe? Who do you owe it to? What is the balance in the account? These are all different types of entries that go into the ledger, right? As we're talking about Bitcoin, which is a currency or a financial thing, we're going to talk about the ledger of transactions, right? So in our case, a blockchain is nothing but a distributed, decentralized ledger that is immutable. What does decentralized mean? Nobody's in control. Everybody who's part of the network gets to look at this, gets to participate, gets to decide what goes on the blockchain, gets to validate every single transaction on the blockchain, and nobody is in control. Second, it is distributed. That means it's not that one person in the network is holding on to the blockchain. A copy of the blockchain can be hosted by every participant in the network. Right? I can set up a full node today, and then the entire blockchain will be downloaded. I can keep a local copy of the blockchain. That means if anybody tries to fool me, I have a copy of my own to verify. Right? If there are 100,000 people who are participating in the network, there are 100,000 copies of the blockchain. Right? That means if one person is lost, one computer is lost, one entire part of the network goes off, you still have enough copies where you can maintain the integrity of the data. Right? Third, it is immutable. That means whatever has been written into the blockchain is a read only. It cannot be modified. Again, it's not that it cannot be modified. Modification involves a cost, and usually people don't want to pay that cost. Right? So let's try and understand how a blockchain is set up. Right? So you have block one, let's say, which has 100 transactions. Once all the block has been completed, there is a set size to the block. Let's say 1 MB, right? Your block is filled with transactions for 1 MB. When the block gets full, you will take a hash value of that block, which is, you can think of it as a fingerprint, right? We understand how hash works. If you take a hash value of something, it is not going to change. It is unique. If you change 1 bit, it changes the hash value completely, right? That means every bit of data that exists right here, if you run it through a hashing algorithm, you will get a hash value, right? In the next block, you will include this hash value and the list of transactions, right? That means the first block has a bunch of transactions. The second block has the hash value of the first block and the list of transactions. Once I have filled the second block, I take the hash of this block. That means this block contains the previous hash value. A hash value is taken of this block, right? And then I include that in the next block. That means every block contains the hash value of the previous block. And these hash values are unique. For example, if I go back in time and try to change this transaction, one transaction that was there, I try to modify it, the hash value will change. If this hash value changes, I have to update this block. If this block changes, this hash value changes. That means I have to update this block. That means you can't go back and modify one thing. If you do that, the entire chain has to be modified. That's how the system is designed. That is why it is immutable. Does this make sense? You create a chain of blocks where one block is attached to the previous block using hash functions. Hash functions are unique. They cannot be, if you change anything in the block, the hash value will automatically change. If the hash value changes, the entire chain is invalidated. Right? So, one more thing that I want you to keep in mind, blockchain by itself is not that great. What exactly does blockchain do? Imagine that you have to write some content. We are dealing with an open decentralized network. That means everybody can participate. Anybody can become a miner, right? The one who's going to make these blocks, generate the hash value, update that, and then get the next block. All of these are done by miners, right? So imagine that right now, I am the one who's going to write the transactions and make the block. How will you incentivize me to keep the correct transactions in the block? Right? Let's say X made a transaction to Y. In the blockchain, I will write I made a transaction to Y. Right? Now that is in stone right now. You can't change it. How will you incentivize me to make sure to maintain the integrity of the block? Right? That is something that Bitcoin has to do. That means you have to build a system that incentivizes miners to maintain the integrity of the block. How does it do that? It says there is a native currency to the system. That native currency is called Bitcoin. When you write a block, for who gets to write a block, we will hold an election because everybody can participate. We will hold an election. You have to come up with a mathematical solution for a problem. If you find this problem, the solution first, then you get to write into the block. Right? Finding the solution is not easy. It requires you to run through multiple hashing algorithms. Usually finding the solution for the next block takes about 10 minutes. That's how the system is designed. It means you have to do 10 minutes of computational work to come up with one hash value. This hash value will determine who gets to write the next block. Right? That means you've already done the work. You have proven that you've done the work. That's your reward to write the new block. You also get a reward of a certain amount of Bitcoins. Right? This Bitcoin is a reward for doing the work. That means if you corrupt the system, if you put in wrong transactions, the integrity of the system is not maintained, the reward Bitcoin that you got is useless because nobody will trust the system anymore. Right? You're already putting in a certain amount of CPU, memory, an entire data center has been set up to mine. That means you're already paying the cost up front. And then the reward is Bitcoins. As long as the system's integrity is maintained, Bitcoins are valuable. If the system fails, Bitcoins are not valuable. Do we understand the incentive mechanism here? Right? So that means the Bitcoin network incentivizes you to maintain the integrity of the chain. If you don't maintain the integrity and if you put whatever transactions you want because somebody's paying you, the amount of money that you spend to actually build this block, right? It's a whole lot of resources. right? It's CPU, memory, electricity, all of these resources, right? You're spending that to get entry into the system and write the blocks. The block will give you rewards. If you corrupt the system, the rewards are useless. That means you spent all this for nothing. That's the incentive, right? I understand this is complicated. If we have questions, we can take it at a later point of time, right? But for right now, I'm just giving you an idea that when you're thinking about a distributed system where anybody can participate, the incentives have to be understood to understand why are people behaving in the system this particular way. What are the incentives for them to behave in a way that is good for the system? How does the system disincentivize or punish the people who are doing things in the network that will harm the system, right? So how does Bitcoin work, right? I'm going to be very, very brief about this. So there is a whole bunch of things that we will talk about in a little bit of detail. Before we get into that, the history of Bitcoin a little bit, right? So it was created by Satoshi Nakamoto. We don't know who this person is. It could be a he or a she or a they. We don't know the actual person who actually did it. It could be a group. They first released the white paper that was done in October 2008. The first block was minted on January 3rd, 2009. This is called the Genesis block. The second user or the miner who joined into the network, also a very a prestigious figure in the Bitcoin community called Hal Finney, right? So he joined the network on 10th, which is about 7 days after, and started mining. October 2009 was the first time Bitcoin was sold against a cryptocurrency. That means it was against fiat, which means it was exchanged for $1,000. Sorry, $1,000 1,000 Bitcoin. That was the exchange rate in 2009, right? On May 22nd, 2010, there's this guy called Laszlo who bought 2 pizzas for 10,000 Bitcoin. This is still celebrated to this day as Pizza Day, right? Bitcoin Pizza Day, right? Again, it's not that the pizza vendor actually took Bitcoin as a currency. He put it on a bulletin board or a forum to say, anybody who's willing to order a pizza for me, I'm going to pay them $10,000. Right? So somebody who also values Bitcoin picked up the order and said, I'm going to place the order to your address, transfer me the Bitcoin. Right? So that was the transaction. And this is him posting the photo after the pizza was delivered. Right? So this is one of those moments in Bitcoin. This is the priciest pizza. We understand 2 pizzas, about $48 that time, 10,000 Bitcoin. One of the most expensive pizzas ever bought. Right? On December 12th, 2010, Satoshi put up his last post and disappeared. This is just after Julian Assange and the WikiLeaks started accepting Bitcoin as donations. Right? So Satoshi realized that it's grown too big, and there might be trouble, because if the originator of the network is known, or if he gets to know, then that is problematic for the network. So he put his last post and he disappeared, and we have not seen him since. Right? So nobody knows who Satoshi is, and the network continues. Right? Now, before we go any deeper, when we say Bitcoin, there are 3 or 4 things that it can actually indicate. We need to understand what are we referring to. When you say Bitcoin, are you talking about the Bitcoin network? Are you talking about the Bitcoin protocol, which is the decentralized peer-to-peer network protocol? Are you talking about the Bitcoin, the currency? Right? If you notice, capital B, small b, right? If again people get confused here, but usually if you're looking at a technical paper, if you see small b, it means the currency. If you see capital B, it means the protocol. And sometimes even people refer to the blockchain, the ledger, which contains all of your transactions, as Bitcoin also, but that's the Bitcoin blockchain, right? Now, when it comes to the currency, Bitcoin is the highest denomination, right? Just like you have 1 rupee and there is 100 paisa, every Bitcoin can be divided into 100 million satoshis, right? That means one Bitcoin is made up of 100 million Satoshis. One Satoshi is 0.0000001 Bitcoin, right? So most people who are doing trading and transferring and doing transactions, most of them are doing it in Satoshis and not in Bitcoin. Bitcoin is very, very valuable today. One Bitcoin, we understand, is about $33,000 today, right? But most people are doing transactions using Satoshis, which is a much smaller unit, right? So keep in mind that one Bitcoin can be divided into 100 million Satoshis. There are other units, millibit and bit. They're not really used. These are just there, but they're rarely used as part of the conversations, right? Bitcoin and Satoshis are actually used in a lot more this thing, right? So let's try to understand what are the things that make up the Bitcoin system, right? There is the Bitcoin network. There are stakeholders. There are transactions that happen. There is a consensus mechanism or a consensus algorithm. Because we are dealing with an open decentralized network, we have to bring consensus to proceed further. If I make a transaction, how does the entire network come to consensus that this transaction is completed, right? So that is called proof of work. Then there is mining, there's forks, and there is mining pools. We'll talk about each one of them in a little bit of detail, right? So first, what is the Bitcoin network? The Bitcoin network, it was designed by Satoshi Nakamoto. It is a peer-to-peer payment network that operates on a cryptographic protocol, right? The participants in the network, there can be a whole bunch of stakeholders. In this, you see three different stakeholders. You see users using their wallets, and miners who are basically mining for Bitcoin. And there are exchanges who will let you exchange your cryptocurrency to fiat or crypto to crypto, right? I have Bitcoin, I want to go buy Ethereum, I have to go to an exchange. I have Indian rupee, I want to buy Bitcoin, I have to go to an exchange, right? So exchanges are going to offer you those services. So the users will send and receive Bitcoins, which is the units of currency, or they're sending and receiving Satoshis by broadcasting digitally signed messages. I will show you how this works, right? In a screenshot by screenshot in a few minutes, I will show you how this works. Every transaction that is being sent is going, and then in the network, it is being validated. It is being added to a central pool of transactions called a mempool, from which the miners will pick up the transactions, make it into a block, and then generate a hash value for that block, advertise it to the network, and everybody in the network will have to accept that block. Once they accept, it is added to the blockchain, right? So let's try and understand what are these terms, and then we'll understand how a transaction happens. That would be the stake, right? So first, who are the stakeholders of this network? Who are the ones who are participating in this network? We have the developers. These are core Bitcoin developers who actually design the protocol, who update it, etc. There are miners who are basically coding your transactions and then making them into the blocks and building the blockchain. There are full nodes or validators. Anybody can become a full node or a validator. It requires minimal hardware. That's how the system is designed. Anybody with a computer with about, right now the size of the blockchain is about 400 GB. If you have a 400 GB, again, it will be more, let's say 1 TB hard disk, and a certain CPU memory network capacity, you can become a full node. Anybody can become a full node and validate every single transactions. Ideally, it is recommended that any vendor, anybody who's offering services, or anybody who has a significant amount of Bitcoin should become a full node to validate your own transactions, to see what exactly is the network doing at any point of time, to query what is the current status of the network, etc. Right? Then there are fourth, these are centralized institutions like crypto exchanges, on and off ramp services, which is basically converting your fiat to crypto, which is, for example, a crypto exchange does between cryptocurrencies, Bitcoin to Ethereum. But if you want from rupee to Bitcoin or rupee to Ethereum, you need to be able to have an on or off ramp services, something like WazirX or CoinDCX, which will do it for INR, or Binance that will do it for US dollar, right? So these exchanges also offer on-ramp and off-ramp services. There's also custodial services. Technically, in the Bitcoin network, each person holds custody of his own coins. That means there is no bank, right? There is no centralized authority. If you are participating in the network, you have Bitcoin, it is under your ownership 100%. So if you lose the keys, it's as good as you lost the coin, right? Because you can't go to anybody and say, I lost it, how can I retrieve it? Because it's completely under your control, right? So if not everybody is okay with that, they don't want that much of responsibility, there can be custodial services where somebody will hold your Bitcoin for you or somebody will hold your keys for you, right? Those services can exist. These are centralized services. Then there are traders, people who go on to exchange and do trading. Then there are users who basically have wallets and they make transactions by sending and receiving Bitcoin, right? These are the stakeholders of the network. Stakeholders being who are participating in the network, what can they do? Let's talk about a few things. First, users. The Bitcoin network does not recognize users. It recognizes accounts. Accounts are basically Bitcoin addresses. So every user will have a wallet. The wallet comes in different types. There are desktop wallets, mobile wallets, hot and cold wallets, there are hardware wallets, etc. Right? So these wallets do not hold Bitcoin, they hold keys. They hold your private and public keys. Right? So there is a mechanism of how these keys are generated. So for example, your wallet generates a private key first. It uses something called elliptic key curve cryptography to generate a public key, and then it does something called a base 58 code check to generate your Bitcoin address, and the Bitcoin addresses are identified in the network. The Bitcoin address can be presented, anybody can send money to that address. It's like an email account, right? You give your email address, anybody can send email to you, but to be able to reply back or to generate a transaction, you will need the password. In our case, that is the private key, right? So the wallet holds the keys for you that you can use to create transactions and broadcast it to the network. The addresses are public addresses that can be used by anybody to send Bitcoin to you, right? So the users will buy or install wallets. The wallets will generate keys. There will be a private key, there will be a public key. A public key will be used to generate a Bitcoin address, and the Bitcoin address can be given to anybody. This anybody can transfer Bitcoins to that address from their account, and then when they transfer, whatever transactions that they do, basically imagine I am sending money to somebody, I will take their Bitcoin address, I will put the amount, I will sign with my private key, and I broadcast this transaction onto the network. When I broadcast it onto the networks, there are full nodes. These devices right here, they validate to make sure it's a valid transaction, and then they add it to the mempool. The mempool is where the miners will pick up the transactions, make enough transactions for one block, the size of the block, include the previous block's hash in it, and then they will generate a new hash for this new block that is being created. There are certain conditions for these hash. This is called a difficulty target, which basically means when you're generating the hash, the current difficulty target will set conditions for you. That means the hash value has to start with 10 zeros. It's a 256-bit hash. It has to start with 10 zeros. That means you have to do multiple iterations till you get a hash value that matches. That's the work that you're doing. That is what we call as proof of work, right? So the miners will have to pick up these transactions, build a block, and then try to get a hash value that matches a pattern. If they find it, they will broadcast it saying, I found it. Everybody in the network will have to accept it. Once that accept happens, everybody will add the block to the blockchain. right? That's how mining happens. So the miners will have to put in the work, and if their block and the hash value gets accepted, they get a reward of a certain amount of bitcoins. This reward has been decreasing. It goes through a half-life every 4 years approximately, right? So in the beginning, in 2009, it was 50 bitcoins per block. Then it became 25 after 4 years. Then it became 12.5 after 4 years. Now it is 6.75 per bitcoin. Again, last halving happened in 2020, right? So in 2024, approximately, there will be another half. It will be 3 point something. And then 4 years later, it will be 1 point something, 1.75 something, right? So it will go on reducing the reward till 2140, 2140, where the rewards will stop completely. From then on, no new bitcoins will be minted, right? That's that. There is also something called UTXOs. Okay, to understand this is a little complicated. Your traditional account keeps track of how much balance you have in the account. Let's say you go to your bank account and they will tell you how much money you have left in the account. Bitcoin doesn't do that. It keeps track of transactions. So the another way to understand this is, think about it this way. Let's say there is a 100 rupee note. You have a serial number of that note. We will track that serial number since its creation, every single transaction, whose account is it in right now, which basically means who can spend it, right? That particular Bitcoin, who can spend it with that serial number. Again, serial number is not there. I'm giving you an example to make you understand that. Let's say that I use a 100 rupee note and the serial number to keep track of who has the rights to spend this note with this serial number. That transaction, that is being kept. That's how Bitcoin does. The ledger is a transaction ledger, not a balance ledger. A balance ledger will keep track of how much balance you have in the account. A transaction ledger will track the entire transaction chain. From the very beginning, the Bitcoin was created at, let's say, 2008, or let's say, let's say it was created in 2015 because it came as a reward to the miner. From then on, where all did it go? Which all accounts did it go to? Who is the current owner of that Bitcoin or that Satoshi? That is what is kept track in the blockchain, right? So UTXOs stands for open unspent transactions. Anything that is not spent right now, as in which account has how much Bitcoin it can spend. We keep track of transactions, not the balance. That's what I want to showcase, right? These are all different types of wallets. We understand there are hardware wallets, which means your keys are kept in a hardware like a pen drive. There are desktop-based wallets where you install an application and that will do key management for you. There are mobile wallets like Blue Wallets and those sort of things, which will keep track of your keys. Please keep in mind that your wallets are not holding your Bitcoin. Your Bitcoin is on the blockchain. The wallets are only holding your keys. Wallets is the wrong word. We should call it a keychain, technically. It can generate and manage keys. It is only managing your keys. The actual Bitcoin is kept on the blockchain. It is not inside your wallets, right? So once you push your transaction, what happens? We talked about all this. The transactions are validated by the nodes. They're put in something called a mempool. Anybody can go verify this. It's called mempool.space. It will tell you what are the current blocks that are up for mining. If you want to create a new transaction, what will be the transaction fees? All this can be seen publicly, right? If your transaction has already been added onto the block, or is it in a block that is still not mined yet, all this can be seen, right? The miners will run massive environments like this that will generate blocks. Again, for this block to be added to the blockchain, they must take all the transactions. They must take the hash of the previous key. If you notice this here, hash of the previous block, the transactions which are currently here, a timestamp, and a unique value called n1s. Together, you will generate a hash value according to the difficulty algorithm, right? You will get a hash. This hash must be advertised to the network. Everybody has to accept it. Only then will this block will be moved into the blockchain and the reward will go to the miner. Who comes up with the hash value first is the computational function. You can think of it as I will give you a Sudoku puzzle. You are supposed to solve it. The first person to solve it will get the right to mine the block. And when he mines the block, he will get a reward of bitcoins. So the Sudoku puzzle keeps getting more and more complicated with the total amount of miners in the network, right? If the number of miners and participants in the network increases, the complexity of this difficulty will increase. If the miners come down, the difficulty will decrease. You might have heard of this recently. China shut down about 70% of its miners. That means the total hash rate came down to 2017 levels, right? That means the total hashing power came down, so the difficulty target came down and it became easier to mine, right? So again, this is also, you have to think about it in terms of an attack. What happens if people or governments go after miners? If there are enough miners who are taken down, the difficulty level will come down. I can use my laptop to stop mining, right? But if there are more miners in the network, then the difficulty target will increase, and then you need sophisticated equipment to mine, right? So this is one of the reasons why it's very difficult to take down the network, because you can't take down one piece and expect the network to fall. It doesn't. It has ways of recuperating, right? Now, we understand that at any point of time, two people can come up with a hash value at the same time, right? Let's say I come up with a hash value, somebody else comes up with a hash value, both of us are advertising. There is a bunch of nodes which have accepted my block. There is a bunch of nodes which have accepted the other block. This is called a fork. Because there are two active these things, if you look at this, a fork basically means this was the blockchain. Because the latest block, there are two of them, because both of them are valid. How do you resolve a fork? The next block that gets mined, the first one to advertise this block or this block, right? Whichever is the longest chain will be taken into account. The short chain will be discarded, right? That means if I generate a block and then that gets added in the some of the nodes have accepted it, there is another miner who has actually sent another block and that is also accepted. Right now, the blockchain has a fork. Now, the next person who mines on top of this chain or this chain, whichever chain gets the first block, will actually be accepted. Whichever is the fork will be discarded, right? So it's good to know what a fork is, but that's it for the discussion for the time being, right? Excuse me, right? So let's try and understand what a transaction looks like. If you are a person who wants to buy Bitcoin, you're not participating in the network yet, you just want to buy Bitcoin directly from the exchange. How will you go about doing that? First, you will have to sign up for an exchange. I've given an example of Binance, but it can be anything. It can be WazirX, CoinDCX, etc. You will sign up. You will transfer fiat money, which is either dollars or INR or anything, into the exchange. You will use that money to trade. You will go and you will see what is the price of Bitcoin versus INR or price of Bitcoin versus USD. You will make the purchase. Once you get Bitcoin, it will be in your exchange. Ideally, if you are going to trade, you will leave it in the exchange. If you are a regular user, you do not want to leave it in the exchange. You will be withdrawing it into your own account. So you will have to choose a wallet, right? And then you will go and say withdraw. You will put your address, your Bitcoin address, and then you will submit. The exchange will transfer that cryptocurrency into your own account. This account is maintained by keys managed in your wallet. Right? This is a transaction where somebody goes to the exchange and makes a purchase. Yeah. Now assume that you already have it in your wallet and you want to send this to somebody else. This is you're dealing with a centralized exchange to buy the cryptocurrency. If you want to do a peer-to-peer transaction, that means I want to send it to somebody else who has a wallet. You first get the Bitcoin address of the receiver. It will look something like this, right? You will go to your wallet, right? Example, Blue Wallet. You will say send. It will tell you how much Bitcoin you have. You will choose how much Bitcoin you want to send. You will put the address here. If it's a QR code, you can scan the QR code, right? And then you can add a note amount, and then you hit send. When you do that, your wallet constructs a transaction, right? It says, I want to pay this much Bitcoin to this address, and I'm going to sign that transaction with my private key. Once the transaction is constructed, it is advertised to the network. It is broadcasted through the Bitcoin network. Everybody in the network will receive it. It takes about 1.5 seconds for the entire network to receive this transaction. There are full nodes which are in the network which will validate the transaction to make sure all the details are correct. The address is valid. You have enough transactions to spend. Your key is valid. There is an appropriate time stamp that is there. There are hash locks which are in place. All of these things are checked by your full node, and the transaction is added to the mempool, right? Which is a pool of all the transactions. As part of this, you will also have to decide, when you're deciding the transaction, you will have to decide what is the transaction fees you're willing to pay. Excuse me. Right? The transaction fees will decide, are you going to the first block or are you going to the last block? If you notice this here, you can say low priority, medium priority, and high priority. How much transaction fees do you have to put to go to high priority? If your transaction is time sensitive, you will put as a high priority. If it is not time sensitive, you will put it as a low priority. You can go as low as 1 single Satoshi for as transaction fees, but that means your transaction will be in the last, right? If somebody else puts a higher transaction fees, their transaction will go first, right? So the miners will come, pick up all of these transactions, use the hash of the previous block, right? And then run their own hashing to come up with a particular hash value that matches the difficulty target. Once they find that difficulty target, once they find the hash value, they will advertise the hash to the network. Everybody in the network will receive it. The full nodes will validate the transactions and the hash value, right? It's like this, right? So the system is designed in such a way that it is very difficult to generate the hash value, but it is very easy to verify. Think of the Sudoku puzzle, right? If you are using the Sudoku puzzle, if I ask you to verify if it is correct or not, it is very easy. But for you to solve the puzzle, it's very difficult. It takes time, right? If you've already solved the puzzle, I can easily verify to find out have you done the work or not, right? That's how the system is designed. So the system is designed in such a way that the miners are going to have to put in work to actually come up with the hash value. But once you advertise the hash value, it is very easy for the nodes to verify if the hash value is correct or not. If it is correct, it is added to the blockchain, right? Once it is added to the blockchain, right? So again, this is an example of what the miner will do. These are all the transactions. This is the target. This is the nonce, which will keep changing for different iterations until you get the target that you want, right? For example, something has to change for you to get the right value, right? If it has to start with 10 zeros, you will try different values of nonce to get the value that you want, right? Once it comes, you will advertise. Here in this example, it has failed. They're trying the next iteration, hashing new, right? Once you find the value you advertise, that blocks get added to the blockchain. Your transaction, let's say, is part of this block. If the next block becomes available, it is called a confirmed transaction, right? If your transaction is still in the mempool, it is an unconfirmed transaction. Once it is added onto the block, you have one confirmation. Every block that gets added on top of it, you get the second, the third, the fourth, the fifth confirmation, because it becomes that much more difficult for your transaction to be modified, right? Because it takes a whole lot of work to generate each and every block. So right now in the Bitcoin system, if you have 6 confirmations, that means if your transaction is currently sitting on this block and there are 6 blocks on top of you, if you have, that means you have 6 confirmations. If it is 6 confirmations, it is secure. It cannot be broken, right? That means you can sell your house, you can sell your aeroplane, you can sell your yacht, and with 6 confirmations, you can be secure that it cannot be modified anymore. If it has 0 confirmations, then you might want to wait until you're actually spending something really expensive. But if you're buying a coffee, it's fine. You know the transactions will go through. It will take some time, but it depends on what is the priority as to how it will be included in it. But once it is included, each block on top of it, it becomes more and more difficult for somebody to modify your transaction. That's what we call as confirmations. Any questions? Right. Okay. So I'll talk about a few attack vectors, not something in absolute detail. It will take another 3 to 4 minutes, and then we'll.
Sir, I have one doubt. Sir, I have one doubt.
Sure.
Is there any expiry date of Bitcoin? Is there any expiry date?
No, there is no expiry date. Right. If you have
manufacturer
a transaction you can spend, it is there. As long as the network is alive, Bitcoins are valuable.
Okay. Second question: who will regulate this Bitcoin? RBI or any other institution?
There is no institution. It's like everybody who's participating has to follow a certain set of rules. This is the protocol that is regulated. There is no authority that regulates it.
Okay. If something goes wrong, then to whom will grievances made?
So what do you mean something goes wrong?
Something goes wrong, suppose some fraud or something, in RBI, there is RBI ombudsman is there. So suppose you want regarding this Bitcoin problem comes, to whom will you put the grievances?
So you have to be very careful before you do the transaction, because there is nobody that you can go to.
Oh, that point to be noted.
Yeah, so the point is this: you have to understand that this is a radically different system, which gives 100% responsibility to you, the user. Right?
Okay.
That means with responsibility, you will have to take transactions because you have so much power. Because it comes with responsibility, you have to understand the system. You have to see how it works. It's like you're making a cash transaction with somebody, right?
Okay.
And he doesn't abide by your contract.
Okay.
If you don't have a set contract, there is nobody you can go to.
Okay.
It becomes your responsibility to verify and check: am I doing the transaction correctly? Am I willing to spend this? Am I willing to give this money to this person, etc.? Everybody can verify. That means who did you send it to? Which account did you send it to? That's all available in the public blockchain. But once the transaction is done, it cannot be reversed.
Okay. Thank you, sir. Thank you.
Sir, I have a question.
Sure.
You said there will be only 21 million Bitcoins, and after that it will stop.
Yes.
Sir, but won't it kind of reduce its value? Because what after that? Is it going to pull strings for something else that will come into power, or
So if there is a set amount, the value will usually increase and not decrease, because it is a scarce asset. Right? Why is the value of gold high? Because it is a scarce asset. Because you can't get it as easily, right? You have to go dig the earth and then find gold, and you cannot make it any other way. It is a scarce asset, so the value will keep increasing or it will stay the same. It will not decrease. Does that make sense?
Yes, sir, a bit, but it's like who decides its matlab, who has decided its value? Because like it will
So
be out of like currently the population of this world is 7 billion,
mhm.
around 7 billion. So out of 7 billion, if only 21 million are going to have this Bitcoin, then what?
So
Like
7 billion people, but 21 million Bitcoin, but each Bitcoin is actually made up of 100 million Satoshis, right? So at right now, Bitcoin is too big in amount to do transaction right now. Most people are doing transaction in Satoshis, right? You also asked how is the value decided? The value is decided in the market, right? How much will this Bitcoin go for is decided by how much people are willing to pay for it, right? If you go to a market and say I'm willing to sell this particular piece of art, people will decide how much they're willing to pay for it. If somebody is willing to pay 10,000 rupees, another person is willing to pay 12,000 rupees, I get to decide who will I sell it this to, right? So it's the market that is deciding what is the value of Bitcoin, right? So that is why you have exchanges, you have price discovery, right? In the exchange, how much are people willing to pay for the one Bitcoin? Right now, it is about 25 lakhs per Bitcoin. Again, it is a really volatile asset. About 6 months ago, it was about 50 lakhs per Bitcoin, right? Because at that point in time, people were willing to pay that much on the exchange to get one Bitcoin. Right now, they're not. And it's not that just with Bitcoin, right? The price of commodities will change as well. For example, the price of oil 6 months ago versus the price of oil right now is different, right? So the market decides what will be the value of Bitcoin, right? You can say, I want to buy it for this price. If somebody comes and says, I'm going to pay extra, the seller will decide who to sell it to. And there's no control that you can enforce. Does that make sense?
yes, I got that.
Right? Okay, let's talk about the attack vectors. Again, we have talked about how the system works. I'm just going to throw out a few attack vectors that are possible. And if you want to compromise the network in any way, what is possible for Bitcoin, what is not. I'm not going to drag out this discussion because this is complicated. Again, not complicated in the sense of how inherently it is. It's complicated for us to discuss it right now because there are too many things involved, right? So first type of attack vector, how can I attack the network itself? There's something called distributed denial of service, which basically means I can go and push in so many requests that it's for the miners to take transactions, right? It's not really possible in Bitcoin as much because there is a cost involved, right? So it is an attack vector. It is not something that will be successful, right? It is very hard to execute on a blockchain network, but it is possible in certain situations. Second, there is transaction malleability attacks, which means I'm going to fake it to the user so that he spends the same currency 2 different times by misrepresenting the transaction hash. There are certain blockchain implementations which are susceptible to this type of an attack. Bitcoin currently has solved this by using something called a segregated witness, right? Again, I'm not going too deep into this. I'm just mentioning some of the attack vectors and how the system solves it, right? So this should give you the basis using which you can do your own research and say what is a valid attack vector, what is not a valid attack vector, right? The third type of attack vector is basically a network-based attack called a Sybil attack, which means I surround a node and feed it wrong information, right? Let's say that there is a vendor who I'm purchasing from, and I want to give him Bitcoin and present to him that his transaction is already added to the blockchain when it is actually not, right? So I can surround every single node that he can connect to and then keep feeding him the wrong version of the blockchain, right? How do you protect yourself against that? If you can find one single honest node, if you can connect to one peer which is honest, then all of these can be invalidated. That's how it works in the Bitcoin network, right? This is not easy. You understand the cost it takes to set up, let's say 15, 20 nodes, and then surround one particular node and keep on giving it wrong information till you complete the attack. There is a lot of cost involved in this attack, right? User wallet attacks, right? User wallets contain keys. There can be phishing attacks that can be done. That means I will send an email. I will let the user put in the seed phrase. The seed phrase is what, if you can think of it as a password that you use to get access to your keys, right? If you put in the seed phrase, you can derive all the passwords, all the keys, public, private, everything, and then they can take all of your money, right? So phishing is one of the open attacks. If you are a user, if you have wallet, you have to be very careful never to put the seed phrase anywhere, right? You have to be very, very careful how the seed phrase, which is sort of your password, is maintained. A seed phrase can be a 12-word or a 24-word password, right? That means it'll give you 12 different words, right? Maintain, power, that, this, etc. 12 unique words will be given to you. That word in that sequence is your password, or a 24-word password, right? You understand how big your password is. So you usually don't remember this. You make a note of this and you laminate that, and then you keep it somewhere in a secure place. If you put it somewhere online, if somebody gets to know that, they can log into your wallet and then take all of your money, right? The second, there is brute force attacks to try and crack, but it's very, very difficult, right? So because it's a 256-bit key, so it will take years, millions, right, to actually crack through. So it is not a viable attack. Even with a supercomputer, it's very difficult for you to do this, right? Again, with a quantum computer, that's a different deal. We'll not talk about it, right? So, and then if the wallet is having an issue during signature generation, right? When it has to generate signatures, if there is a known vulnerability as part of that, that can be compromised. If your wallet is being compromised because of flawed key generation, because your private key has to be generated using a random number generator, a 256-bit number, random number has to be generated, right? So if there is a known mechanism in which it is creating and it is not really random, that can be used as an attack vector. There is a whole bunch of other things. For example, Ledger went through an attack recently where the company database was hacked and all the users' detail was hacked, and there were some innovative hacks that came out of this. Once this hack was completed, the hackers got to know who are all the, let's say, consumers of Ledger. They sent them full-fledged hardware wallets and told them, sorry for the compromise. We are giving you a new wallet. Please go ahead and put your key in here and start using it. This new wallet was actually a compromised wallet. That means they gave you a hardware that was already compromised. If you plug that in and if you put your password, it will steal your money, right? So again, because it is a decentralized network where everybody, you can think of what Bitcoin does. It makes every single participant, every single user as his own Swiss bank. Right? There is no need for an intermediary in between. You can do your own transaction, you can maintain your own accounts, you can maintain everything by yourself. It's a lot of responsibility, right? It gives you freedom, but it comes with responsibility. So if you cannot handle that responsibility, ideally you should be very careful or find somebody who can help you with these things, right? That's where these attacks became prevalent. Attack vector 3, there is transaction related attacks. Double spending is an attack. So think about it this way, right? So if you have your internet is a network of information, it lets you duplicate information really, really easily, right? I can have 1 million copies of a PDF document and it doesn't really matter. But if you're going to create a network of money or network of value, you cannot have duplicate items, because if I can spend the same money at 2 different places, the value of the money doesn't exist. That means you have to create new mechanisms to stop this double spending problem. So the Bitcoin comes up with a system which basically is That's where the miners and the proof of stake and the consensus and all of these things come in, right? All of these things together will tackle the double spending attack, right? Second is alternate history attacks, which is basically creating a completely new blockchain and advertising it. Again, we understand creating each and every block takes effort. You have to generate the hash value, you have to advertise that block, people have to accept that block. There's a whole bunch of things you have to do just to get one block in place. Alternate history attacks take a long time and a whole bunch of resources to do. Is it even worth it? Is the first question, right? Why do you want to spend so much energy to create an alternate chain and present it, and you have to get people to accept the new chain, which is not easy. There's 51% attack, which basically means I take control of 51% of the miners, and then I get to decide what will be the valid chain. How do you protect? Again, there's a whole bunch of cryptocurrencies which have already gone through these attacks. Verge, Zencash, Monarch Coin, Bitcoin Gold, Litecoin Cash, Ethereum Classic, they've all gone through it. There is a rumor that right now Bitcoin SV is going through one of these 51% attacks, right? 51% attack is a valid attack for a small chain, but Bitcoin is not really vulnerable to this because it is too big right now, right? If you have too many people in the network, getting 51% requires a whole lot of resources. It's not easy, right? So 51% of Bitcoin is not even a viable attack at this point, right? Maybe if, again, I'm not saying it cannot be susceptible. If enough people are taken out, if enough miners are taken out, it could be, but at this stage, there are other fail-safes that are built into the protocol, right? So coming back to the discussion, let's try and understand each and every stakeholder. If he tries to compromise or take over the network, how does the system protect itself, right? Every time you're trying to understand this, I would recommend you use this logic. Who are the actors? What are they supposed to do? How is the system incentivizing them to do what they're supposed to do, right? First, the developers. They get to decide the code that will be run by everybody, right? What if they try to take over the network? They try to put in malicious code that does something. How does the system protect itself against that? Miners and full nodes, which have to actually run the code that the developers publish, have a full veto power. That means they can just say, this code I don't want to run. I will run the old version of the code, right? That means the developers do not have the power to push code unless and until the community actually accepts it, right? Everybody has to agree to do the updates. If people don't agree, you can't push the update, right? Second, if for some reason you pushed the update, I can go back to the blockchain, which is immutable, discard a certain amount of blocks, and then start over from a different point and create a new chain. This has happened, right? Second, miners. What if miners try to take over the network? First thing, who gets to be the miner who gets to mine the block is random. It depends on who gets to generate the hash value. It is not deterministic. If it is a random iteration of who gets to actually mine, there can be 1,000 people who are trying to mine. Who gets the hash value first? You can't really get that. Even if you have 51% of the mining power, that doesn't mean that you get the next value, the hash value. Somebody else outside of your control might get it, right? So it is random. Second, there is game theory. There is incentives built in play, right? The 51% attacks, if you have 51% of the network, it is more profitable for you to run the network rather than try to compromise it. Because if you compromise it, you will lose everything that you put in, right? To run the 51% attack, you have to build data centers, you have to build hashing algorithm, you need to do hashing, you have earned the amount of Bitcoin. All of these things, you can continue to earn Bitcoin because you keep getting these hash numbers. But if you compromise it, all that goes to waste. You have basically burnt your money, So there is more incentive to continue to maintain the integrity of the network rather than break it, right? And of course, there is a real world cost, because you have to set up data centers, you have to set up massive rigs that do hashing, right? And of course, if you try and put in wrong transactions, the full nodes can still do a veto, right? The full nodes can say, I will not accept your new block because there is some malicious content in there, or you have not done the mining correctly, right? Full nodes are vulnerable to Sybil attack. The full nodes don't really do anything, they just validate, right? So, and there are thousands of them. There are 10,000 publicly available full nodes, and there is about 100,000 or more available on the Tor network, right? So you can't take it down, right? What are they vulnerable against? Sybil attacks. That means you covering and then giving the node wrong information. How do you protect against that? Find one single honest peer. There are many publicly hosted honest peers which have been there in the network since the very beginning. Some core developers have their own nodes which are publicly available. You connect to one of them and you get the full copy of the chain, right? And it is too high a cost to actually bring them down because there are so many of them. Centralized institutions can be brought down because they are centralized. They can be hacked. Now, we understand many exchanges have been hacked, right? Custodial services are basically a honeypot. They're just there holding on to this currency. They can be hacked. They're partially protected by proof of work because it takes effort, but they're not completely protected because they are a centralized entity in a decentralized network. They stick out like the sore thumb. They will be attacked, right? And of course, there are traders and users. So what are my conclusions? Overall, the entire talk, when we are dealing with an open, public, decentralized system like a Bitcoin blockchain, your system has to be designed with enough care to take security as an inherent feature, as an intrinsic system, right? It cannot be external to the system. For example, security of the Bitcoin blockchain is due to the following. If you can, I understand that I discussed a whole bunch of technical things today. If there is one thing that you want to take away from this entire talk, it is this, right? What guarantees the security of the Bitcoin blockchain? Decentralization, that means nobody's in control. Randomness, who gets to mine the next block is random. Game theory, that means built-in incentives to punish people who are harming the system and incentivize honest nodes because they get more rewards. Real cost, that means it requires, for you to start mining, it requires you to actually set up an entire system. And cryptography. Most of all, Bitcoin is really, really simple. The entire purpose of Bitcoin is to do one thing and one thing only: be money or currency. That's it. It is not vying to do all of these smart contracts and all of this, because when you complicate the systems, the attack surface increases and the attack vectors increase. If you keep the system as simple as possible, where it's doing only some very specific thing, it's much easier for you to secure it. And with that, I end my talk. Thank you.